everyone. So I'm going to tell you about why to study compiler design. So before we start with why to study compiler design, let us go with the introduction. So when you go with the introduction, so basically programming languages are the foundation of modern software development. Without programming languages, we cannot develop any software. To learn how the program are developed, so we should know some of the basic concepts of how the compilers are designed. So now when you talk about what is compiler design, basically a compiler design is the process of translating high-level code into efficient machine code or intermediate representation. Basically, what it is going to do, so basically when you talk about the layman's definition, so basically a compiler is nothing but what, which is the process of converting high-level language to machine-level language. So basically this compiler design is very crucial for developers to become proficient in software development. So without knowing the knowledge of the compiler, so we are not able to write a proper software for a particular language. Okay. So now when you're writing the software for a particular language, so we should know what are the complete internal structure of the compiler is designed, how you can do it. So basically we should have the understanding of the programming languages. So basically when it comes about the understanding of the programming languages, compiler design provides an insights into the working of programming languages. How it is going to provide you the insights is the next thing which we have to discuss. So basically it tells what type of hardware you are using for that particular hardware, how we have to write the compiler, because the different you talk about the compiler design. So the design of the compiler basically depends upon the processor which you are working on. So it depends upon the working of the processor also which you are going to have the worker, and that particular language is also depend upon what type of hardware you are using. So it basically learns about language semantics and syntax. It basically what it is going to lead. So it is going to lead to writing cleaner and more expressive code. So the programmer can write the right cleaner code with the help of the more proficient compiler design knowledge. So if you don't have the compiler design knowledge, the programmer cannot write the efficient code which he has to develop. So when it comes to when he is developing the compilers, so you should know what are the different methods you can use to optimize the code, because there are some of the limitations which you are going to have when you are using a particular software to be um, deployed in some places, especially with respect to the real-time operating system. So when you want to build that particular thing, so we should have some optimization techniques. So when it comes to the optimization techniques, so what optimization techniques, so in this one, the compilers plays a vital role in optimizing code for better performance. How it is going to play important role in optimizing the code for better performance? Because the different hardware requires different types of optimization. So when it comes to the normal OS, we don't have any time bound. Whereas in your talk about the real-time operating system, it is going to have the time bound, where some actions has to be taken within the fraction of a second, and we have to have the space complexity should be there and time complexity should be there. So the optimization technique, it has to do with respect to space as well as the time. So I have to reduce the code of the software, and then that particular code of this reducing the code of the software without having the degrade in the performance that have to make. So how we are going to make, so that we are going to do with the help of the optimizing the code. So it plays an important role in optimizing the code to have the better performance also. And it also explores the various optimization techniques. So we are going to have some of the techniques which you are going to use for the optimization techniques of loop unrolling, constant folding, and register allocation. So when it comes to loop unrolling, so it is going to unroll the loop. So it is not going to execute in the sequential manner. So which are the registers free and what are the actions to be which has to be taken in parallel. So that will be taken into consideration, and those loop will be executed in parallel. So when it comes to the register allocation, so if any of the registers are already used by some of the other instructions, so the which are the free registers are there, the compiler has to see that particular register depending upon the hardware architecture, and that particular register has to be provided the facility to use that one. So by using the resources efficiently, we can write the faster and resource efficient programs where we can have the speed of the program can be improved as well as the space can be compromised. So we cannot, when you go with the optimization techniques, when it comes to real-time systems, so your space and time both will play an important role, because we are going to have the smaller space where that particular software has to be built, and we are going to have the performance has to be taken into consideration. So when it comes to the optimization techniques, so once you have do the optimization with respect to space and time, first that particular code has to be generated in efficient way, which tells about your efficient code generation. So now when you are writing your efficient code generation, so the compiler designer should know how that particular compiler is going to translate from high level language to low level language code. So if it knows how it is going to translate from high level language to low level language, it basically improves the code efficiency. So by it is going to increase the code efficiency by having the detail of the things which is running in complicated manner. So that is what it is going to be improving the efficiency. So it is going to basically improve the code efficiency by understanding the intricacies of code generation. And it is going to create the software that executes with maximum speed with minimum resource consumption. So that's what it's going to have. So when it comes to the real-time operating systems, okay, when we are going to have the real-time systems as a built, so in the real-time systems as to be built, so where your space and time has to be taken into consideration, and whatever the design real-time systems we are going to build, so that should be compact. So when it's going to have the compact means what? So sure we are going to have the minimum resource consumption in that one. So that will be taken care when you are writing your compiler efficiently. So next, when you are going to discuss with respect to the compiler, so basically it is going to provide you the feature of portability and interoperability. So that means what do you mean by portability and interoperability means? So basically the compilers enables cross-platform development and execution. So next comes the question, what do you mean by cross-platform development and execution? So it is nothing but whatever the program, for example, if you are writing your C program, the C program can be built using the Turbo C compiler and GCC compiler, and many other C compilers are there. So when you are developing with respect to cross-platform development, so if you execute that particular build the software in one platform, so the same software should run in other platform also. So when you are going to have that particular feature, the portability will be solved. That means if you are running the same application using Turbo C or Windows compiler, so which is of 32-bit, so the same software has to be the same software which you have built has to run with the compiler of GCC, which has been built. So that has to be taken care into consideration. So when you're writing all these interoperability type of languages, so the basic study shows that how compilers facilitate writing code in high-level language and translating it to the machine code. So which just can be put into the different platforms. So when you're putting into the different platforms, so that whatever the program you have been written or whatever the software you have been designed, so if it is working fine under Windows, the same software which if you deploy in either in Macintosh or Linux operating system, the software should work properly. So that is what it has to facilitate. So the compilers has to be designed which has to be executed in efficient manner so that it should work in all type of platforms very effectively. So basically this is particularly developing software. So it basically runs seamlessly on various devices and operating system. So that is nothing but if you go with the real-time operating systems, there are a number of real-time operating systems or a number of systems which you are going to build. So in that particular a number of operating systems in your real-time systems which you are building, so those uh, hardware should not stop when you are executing in one platform and you are deploying that one in the other hardware. So that should work properly. So that is what the portability and interoperability questions is going to come into the picture. So the next features which the compiler will going to have is error detection and reporting. So when you are designing your compiler, so compilers basically checks what so your syntax error and static analysis takes during compilation. So as you know, whenever the program starts running, so it's going to detect that where you have gone wrong. So syntactically wrong if you are going with that one. So latest in the latest stage, if you are going to detect after syntax analysis, if you are going to have some logical error, so some error, there's some mistakes, it is going to show that at this part of the line, that particular logic has been missed and that you have to correct it. So when you're going with a syntax error, it is going to point to a particular line. But when you come to when you're discussing with respect to logical error, so that will not point to the one line. So that will point to the different line where that logic will be residing, which you have to rectify in the different line. So that you have to rectify that particular logic in one part. So almost of the errors will be recovered at that time. So when you are doing all this error detection mechanism, So identify the program mistakes. This will be done in the early stage of the development lifecycle itself. So if you are finding the programming mistakes early in the development lifecycle, so it will become easy for you to develop the software. So the software which you are going to build, so it will become more reliable and it is going to have the lesser number of bugs which you are going to have. So if more number of bugs are there, then it will become not a efficient software. So the software which you are going to build is not an efficient one. So next one is going to have this particular error detection and reporting. So how this particular language is been implemented, how the implementation of the language is going to be done with the help of the compiler design. So when you talk about the compiler design, so it's basically essential for creating custom programming languages or domain specific languages. So when you call, so when you're designing a custom programming languages, so compiler design plays an important role. So if you're going to traditional programming languages which you're going to use, so that will be having like C or C++. So you should know how to design the compiler for your C program, C language, or for Java program. So R language. No, many of the languages are there which are in the market. So for the different purpose, we are going to make use of the different programming languages. Or if you are going to write with respect to domain specific languages. So if you're going with data scientist, if you want to become, we are going to have some sort of domain specific languages like R language is there, Go is there. So you can use that some of the domain specific languages to have to work on particular domain. So if you're going with like that, if you're going with the Internet of Things, so you should have to build the software with the help of a particular compiler. So, so for that particular reason, the language implementation plays an important role. So it basically gives an insight into designing parsers, analytical analyzers, and semantic analyzers to build a custom languages. So when you plan about getting the insight, so what it is going to print. So where that particular when it is reading from one cat, when it is reading the in the first stage of the compiler is going to take place. So it is going to read the character by character. When it is going by character by character, how the syntax has to be formed, what has to be done first. So which has to come first and which has to come next, and subsequent phases which has to be done. So everything will be scanned one character at a time. So when it is scanning at one character at a time, you come to know that where the error has been occurred. So what are the syntax for the particular program language which you have to follow. So if you're not following a particular syntax for that particular programming language, so obviously the error is going to come. So this what is going to make. So basically this is going to make you to develop a tailored solution for specific application domains. Okay. So you are going to provide you the solutions for the specific application domain. That means whatever the language you have been built, so that will be running, that software is going to run in a specific application. Okay, so it is not going to only it is going to be for specific applications, because when you are written the application to write the data analytics, so the same application which you have been built is not going to work for every Internet of Things or any other. If the same may not be working fine with respect to the security, or same may not be working fine for with your cloud computing. So whenever you are going to have the language implementation, the different languages is going to support for different applications. So that we have to take into consideration when you are thinking about the language implementation. So next is the security considerations which you are going to have to take into consideration. So now, what the impact of compiler on security? So basically, when you are designing your compilers impact the software security. How? Next comes the question, wow, how it is going to impact the software security? Because if the compilers, so if the compilers, if you are designing, so it's going to have the more openness. That means if you are designing that particular what is happening inside and wow, how the guesses can be done, so how the compilation is going to take place. So it will become easier to understand how the compile optimization and transformations can be introduced. So if you know how the optimization and transformation can be done, it will become easier to introduce the vulnerabilities. So if it is easier to become the one introduce the vulnerabilities means what? So you can introduce any viruses. So this particular, if you are if you are becoming efficient compiler, so you can become a good virus developer also, because you will be knowing that how to develop the virus, what are the effect which you're going to have, what are the effect it can do with respect to the compilation stages with respect to your virus, so that you can do. So it is going to learn the mitigate security risk and to build a secure software which you're going to have it. So when it comes to the next part, so I'm just going to have the debugging and profiling. So when it comes to debugging and profiling, so basically it gives a knowledge of comparison aids in understanding and interpreting generating code. So how it is going to, how it should have the knowledge of compiler design. So it is going to have the understanding and interpreting generated code. So if you know all these things properly, if you know it is working, so then it will become easier for you to debug. So and where the particular error has been occurred, so it will become easier for you to, and where the bottleneck has happened. So if any of the software is working in unexpected behavior, so whenever you are going to have the proficient knowledge of the compilers, so you'll come to know that why that particular software is not working properly. So where may be the bottleneck which has been occurred. To overcome that particular bottleneck, what are the countermeasures have to take? So all these things you have to you can do it by having the knowledge of compilers. So basically what it does, so basically it is going to optimize and fine tune software for better user experiences. So these are some of the advantages which you are going to have if you have the knowledge of compiler design. So next comes into the career opportunities. So compiler design is basically specialized in software skill in the software industries. So most of the programming languages working with most of the people who are working with the new programming languages, obviously they have to develop the compilers. So they have the requirement of compilers. So and the perform when you are going to have the performance critical systems which are to build, that is real time systems which you are going to have. So the real time systems you are going to have the specific set of hardware which you are going to have. So whatever the compiler you are going to design, so that compiler has to compile with respect to the only that set of hardware which you are going to use it. So these are nothing but the critical systems which you are going to have, like if you are going to have a humanoid robot, or if you are going with the defense equipments which you are going to have. So these are the places where you are going to build your performance critical systems. So in those where you are going to have the performance critical systems, so it plays a vital role of having the job opportunities with respect to the compiler design. So it is basically unlock the exciting career opportunities in software engineering. Okay. So when it comes to the conclusion of overall how you have designed and why you should learn the compiler design. So basically studying a compiler design is essential for becoming a proficient software developer. Okay. So it basically gives a deeper understanding of programming languages and how you are going to detect the error inside your application and how the code can be optimized so that you can learn it. And also it enables empower yourself to write efficient and portable and reliable software. So advancing your career in the software industry. So now when it comes to the industry, so for a compiler designer, the salary is ranging from 20 to 25 lakhs in the starting pay only. So only you should have the proficient in your compiler design, how it is designed, or for what architecture you are going to design your compiler. So that you should know properly. So that if you know all these things, so obviously the market is very wide, so you can get an enormous job inside your software industry. So thanks for listening